All right, hello. This is objective where we will be able to apply the segment addition postulate, which is a super useful postulate. We'll start with our important vocab. So perpendicular is when two lines intersect that are 90 degrees, intersect a 90-degree angle. Bisect means to cut in half or split in half. Expression is just like math language. So let's say like x plus 3, right? We're just using numbers and mathematical symbols to express a value. Equal is when we talk about the same quantity. Use the equal sign there. Equation is when we have an expression that's equal to a certain value. Like so, x plus 3 being equal to 10. Congruent means same size and shape. So it's when we're talking about stuff being kind of the same, but size and shape versus quantity. And then an arc is just a curve. All right, so in class, we kind of discovered how we could use the segment addition postulate with Twizzlers. I'm just going to get straight into the segment addition postulate down here in the key points box. The segment addition postulate says, if you look at this picture above here, if point C lies on AB, then AB is equal to something. So if AB is like this whole yellow length, I can think about the other segments. Now, as soon as I put like C on AB, that creates a segment AC. Whatever that length is, plus however long from C to B is, that is equal to the length of AB. Like I can add these two parts to give me the whole thing. The orange part plus the pink part gives me that whole yellow part. Okay, so this is helpful because let's say I'm finding the length of segment AB here. And I'm told AC is this whole length and B to C is 5. Well, if I think that A to B plus B to C is equal to A to C, then what I can do is be like, well, I don't know what AB is, so let's just call it X. BC is 5. Whatever ABX plus 5 is has to equal A to C, which is 9. Got a little equation now I can solve. X plus 5 has to equal 9. I can subtract 5 to find what X needs to be. X is 4, so AB is 4. And that makes sense because 4 plus 5 equals 9. Okay? Now, if we have a midpoint on our segment, then the thinking can be a little bit different. A midpoint is a halfway point that divides the segment into two congruent parts. So two parts that are the same size and shape. A way that you can see if a point is on, that if something is a midpoint, it's if that point is on the perpendicular bisector of a line segment, then it is equidistant from the endpoints of the line segment. And a perpendicular bisector, what that looks like is here. If you say C is the midpoint of AB, you can use a compass essentially to create this arc and then this arc. And here, let me grab a compass really quickly and show you. Sorry for that delay. Okay, so if I like extend my compass from here to here and I create an arc and then I go from the other endpoint the same distance and draw another arc, where they intersect, right, this segment that is formed is called a perpendicular bisector. It will intersect the segment at a 90-degree angle, and it means that this point is in the middle. Okay? So, is point C the midpoint of AB? In this case, yes. Because C is on the perpendicular bisector of AB. So if you see like this picture with these two arcs intersecting and then the two arcs being connected with this segment, this yellow thing is the perpendicular bisector, and then you can know that this point is the midpoint. Now when we have midpoints, we want to use congruency marks, which look like tick marks to show when segments are congruent. So for example, if I have this and I know that I'm told, or I know because I actually do a perpendicular bisector, but that Q is the midpoint, then I can put these like tick marks to show that PQ is the same length as QR. So PQ, I can say, is congruent to QR if I see these little tick marks on the same two segments. All right, and then this is going to allow us to find segment length. So if AC is 32, so if I go A to C is 32 units, find the length of AB. Well, because I see these tick marks, that means AB is congruent to BC. So they got to be the same amount, the same length. So then what I can do is just take this 32, divide it in half. 32 divided by 2 is what? 16. So both of these are worth 16. And it makes sense according to the segment addition postulate. 16 plus 16 is equal to 8, is equal to 32. It's just the difference is if I know these two are the same, if I see these tick marks, then I know these two lengths have to be the same length, so the same number. Okay? I'm going to jump to our next key points box. That's a little bit more about midpoint. Oh, and the segment addition postulate. So, with these examples, example 4 says find the length of segment NP. Now we're going to find segment length using algebraic equations. Notice, there are some variables here. There are some expressions here. So, I can still follow the segment addition postulate if I know all three parts. So if I have like a line N in between two endpoints and I know the value of Mn, Np, and M to P, then I can follow the setup that Mn plus Np will equal M to P. Then just plug in what Mn is worth. Mn is worth X units. Np is 2X plus 5 units long. Those two added up will be equal to the length of MP, which is marked as 32. That's going to allow me to solve for X. So X plus 2X is 3X's plus 5 equals 32. Subtract 5 from both sides. You get 3X equals 27. Divide by 3. And you're going to get X equals 9. Now, notice the question didn't ask me to find for X. It asked me to find the length of NP. And NP is worth 2 times X plus 5. So NP is equal to 2 times whatever X was, which we found was 9, plus 5. When I do that math, NP is equal to 23. And now that makes sense because if this is 23 and Mn is worth X, which is 9, 23 plus 9 is 32. So that tells me I found the right value for X. Example 5 says find PQ. All right, well, I'm looking at this. Now noticing P to Q is, I'm not given a length for PQ, but I am told that PM is 2X plus 8 units long and MQ is 5X minus 4 units long. And I'm noticing my tick marks. So that means PM is again congruent to MQ. So that means 2X plus 8 has to equal 5X minus 4. So notice, if segments are congruent to each other, then you can set their expressions equal to each other. So let me just solve this. So I'm going to move my x's to the right side, so subtract them from there. That leaves me with 8 equals 5x minus 2x is 3x minus 4. Plus 4 plus 4, 12 equals 3x's. Divide by 3. Well, and get x equals 4. And again, it wanted P to Q, so I'm not done. It wants what PQ is. So I have to find, okay, 2 times 4 plus 8 is how I find P to M. So that's 8 plus 8 is 16. Let's do 5 times 8. Oops, sorry, 5 times 4. Minus 4 is again 16. And hey, that helps me check my work. I got the same value for PM and MQ. Then it wants PQ. So now segment addition postulate, these two added up PM plus MQ will equal PQ. So 16 plus 16 gets me 32, which is equal to the length of PQ. Okay. Last example says if PQ is 18 inches long, find X. All right, so PQ, I'm looking at this picture, what do I notice? I notice I'm told PQ is 18, so I'm going to label that. We can use these like kind of brackets like to show from like, hey, starting here and then over down to here, it's worth 18 units. PM is labeled as 3X. Oh, I'm noticing the ticks again, so they're the same. So I can, if that's 3X's, then that's where 3X is. So something else to notice, if segments are congruent to each other, then you can use the same expression, that 3X that we did here, to represent both segments. And then I can follow my segment addition postulate, right? I can say PM plus MQ is equal to PQ again. So that would mean 3X plus 3X's equals 18. 6X equals 18. Divide by 6, X equals 3. Now, it asks for X, so I'm actually done now, but let me check my work. 3 times 3 is 9. 3 times 3 is 9. So I'm like plugging in my X value. Oh, and 9 plus 9 is 18, so that really makes sense. The other thing that I could have done here is, because I know that these two segments are the same, then that means like I could cut this 18 in half and say, okay, each of these is worth 9, and 9 has to equal 3X. And then I could solve that equation and still get X equals 3. Okay? And that's it. Hope that made sense. Here's my penguin showing you some geopower. Okay? Have a good day.